In this review, we'll take a look at concepts that are involved in energy and energy conservation. The big idea when it comes to energy, and most physics problems talk about how energy essentially remains constant in a closed environment. And by closed, we just mean that energy can't leak out and go other places. Here, if we consider the skater, the ramp, and the earth, all of the energy that's present in this system can't go anywhere else. Because of that, the total energy in this system, notice, is always a constant value. That doesn't mean that types of energies have to be constant, it just means that the sum of all them is actually constant. So here the big concept, it's just that the energy before something happens is always equal to the energy later on in that closed system. Again, this is only for closed systems. Most of the physics problems you'll see then talk about three types of energy. One of those types of energy is energy of motion, otherwise known as kinetic energy. Kinetic energy is dependent upon only two things: mass and how fast something travels. The model is 1/2 mass times the speed squared. So you can calculate the kinetic energy of a car as long as you know what its mass is and as long as you know how fast it's going. Another type of energy is the energy that's stored in a spring. In this case, the energy depends on how much the string is stretched and also how stiff the spring is. Here, it's 1/2 times the spring stiffness, or Hooke's constant, K, times the distance that the spring is stretched or compressed, squared. All you have to do on this is make sure that your units actually work out. If your spring constant is in newtons per meter, make sure that the distance or stretch or compression is also measured in the same distance unit that you use over in the spring constant. The last type of energy that you need to be concerned with is what's called gravitational potential energy. This is an energy that an object has relative to its position in a gravitational field. So if you have a bowling ball that's on top of a bookshelf, it's going to have gravitational potential energy because it could fall down to the ground and do some damage. This energy is related to the object's mass, the gravitational field strength, and how high it is above a common surface. That energy is simply the product of the three things: mass of the object, gravitational field strength, and the height. Or you can write down x or whatever value or variable you'd like to use for the height. But then again, that's always above some sort of a reference point.